On feature, and then once I did that, I wanted to reflect it around a line, so I used the slider to create a variable m and b, and then just typed in y equals mx plus b to make this line, so I could slide where the line is, and then all I had to do after that was go to this reflect object around line and just pick the object and then pick the line, and it makes it so it reflects the triangle based on where I changed the line. And then I can also move around the triangle however I want to. That's pretty much it.
Basically, I just created 2 sliders for the lines for each triangle, and then you can adjust the angle you want. And it just kind of demonstrates congruence. Get a good indication of how it works.
How did you create a slider for the angle?
Right here. It's angle with given size, and it just says put on the leg and then the vertex, and then I just entered the size as my angle.
If you go up to a slider too, go ahead and insert a slider real quick.
Okay.
If you go to number or angle,
Then you get some value.
First I created my octagon, and then I labeled some of the, I wanted to show that students that if you move made your sides smaller or something, you notice that all your sides change, but your angles stay the same. I measured a couple different angles, and it shows that. And I've got the area that, I also put the area in it. And after I was done doing that, then we went and inscribed, I got the midpoints between several lines, and then when I got that, then I found the center of this and went out to a radius. I went from a circle with a radius, and then it created the circle then for me. So, and it had to be purple.
thank you.
As for the construction of this, it's very, very simple. Just have 5 sliders out here. Is there any easy way to zoom out?
If you just scroll, it zooms. You might have to click on your individual sliders to drag them.
I fixed them.
Or you could just move your whole GeoGebra window. Oh, no. Yeah. Well.
Oh.
Okay.
Or close the algebra window.
Hey.
Okay, so I just 5 sliders, and what the sliders do, they change the coefficients of this quartic polynomial, but it's defined as a function. I couldn't put it in that way. But anyways, if you move these sliders,
Well, go over on your toolbar to the move thing. There you go.
so if you move the sliders, you can see how each coefficient affects the graph. And D and B play with the legs a little bit. And then C does its own thing, as well as A and E. E just moves it up and down, obviously.
Cool.
But an interesting thing here is you can see when these functions are going to have real roots. When it's going to have 4 real roots. Right now it has 4 real roots. If you move it up, now it only has 2. Keep going. Obviously, when this is above the x-axis, it'll have 0. So.
Very good.
So over here I've got, you can just do the cosine, or you can do both, or you can just do the sine. Right now I've kind of got it set up. You've got 3 coefficients, so the k number is frequency, omega is like the phase angle, and then a is the amplitude. So you can increase the amplitude either positive or negative to make a bigger or smaller sine or cosine. And then you can move the phase angle, so it can go back and forth. And then you can change the frequency, so it'll be a little bit smaller or a little bit bigger. Hold the period, I guess. And then you can do that with the cosine, and it follows the same thing. So you can see how both of them are kind of related, and they're off by a certain amount, like pi or 2 or whatever.
Mhm.
So that's fine.